geometry, let's take a look at the law of sines. So as far as we've been working with triangles in class, we've been working with right triangles, doing right triangle trig and using the Pythagorean theorem. However, now we're going to use triangles that are not right triangles, and we're going to find missing sides and angles. And one of the ways we can do this is something called the law of sines. You'll notice the law of sines has lowercase a, lowercase letters are for the side lengths, and has capital letters. Capital letters are for the angle measures. And you'll notice that the lowercase side a is across from capital A, lowercase side c is across from capital angle C, and lowercase side b is across from uppercase angle B. And you'll know notice the law of sines is the length of the side over the sine of that angle. The length of that side over the sine of that angle. So it's the length of a side over the sine of the angle opposite it. And you can combine A with B, A with C, or the other combination is B with C. So let's jump in and take a look at one of these problems with numbers. So let's take a look at number 1 here. Whenever I start a problem like this, I always look for the angle that we also know the side opposite. That's a really good one to use since I know both of the angle and I know the side opposite. So in this case, when I go to set up a proportion, I'm going to definitely use this side A, which I know the 42.9, and this angle capital A, I know the 32. So I know to start that A over sine A is something that I'm going to be able to put in for both of them. Now let's look for what else you know. Well, I happen to know angle B is this 81.8, but I don't know side B. So I could probably set something up where I could use A over sine A equals B over sine, I'm sorry, that should be sine B, I'm so sorry. Sine B, because I know A, I know angle A, and I know angle B, that will leave me with one unknown. So if I put my side A, which is 42.9, over the sine of angle A, which is 32, and then B I don't know, over sine of its angle, 81.8. So now I'm going to multiply this sine of 81.8 up and away from my variable B. I'm going to multiply it over to the other side. And now I know that B is equal to, I'm going to write the 42.9 in front because it's like a coefficient, times the sine of 81.8 all over the sine of 32. So I'm going to grab out my calculator and I'm going to do 42.9 times the sine of 81.8 divide by sine of 32. When I do that, I get 80.13 centimeters for the length of B. 80.13 centimeters for the length of B. So now that I've done that, you'll notice I don't know angle C, nor do I know side C. But angle C is super easy to come up with. Let me change, because now I'm concentrating on a different angle. The triangle has 180 degrees, always. So I'm going to do 180 minus the 32 I know, minus the 81.8 I know. And when I do that, I get 66.2 degrees. So I know this angle C is 66.2 degrees. So now I'm going to set up a proportion again. This time it's side C I don't know. So I'm going to put it over the sine of angle C, which is 66.2. And I have an option here. On the other side of this proportion, I could use A or B. I'm going to go back and use A because that was given to me in the beginning, but it won't matter which one you use. So I'm going to write side A, 42.9, over sine of A, which is 32 degrees. And I'm going to multiply this 66.2 over to the other side. So I have 42.9 times sine of 66.2 all over sine of 32. And I'm going to put that all into my calculator. And when I do, I should get something near 74.07 centimeters. 74.07 centimeters. And this was 66.2 degrees for angle C. So let's take a look at this problem again. So I always look at my problem and I try to identify the side that I also know the angle. But you'll see in this problem, I don't seem to know an angle and the side because I don't know B and I don't know side A. However, we were just talking about how I can find the third angle if I know the other two. So I'm going to take my 180. Oops, sorry, I thought I went to pen. I'm going to take my 180 minus 37 minus 48. And when I do that, I get 95 for C. So now you guys will notice that I know angle C and I know side C. So this would be a great ratio to use to start my proportion. So I know 18 over sine of 95 is equal to, and now I have an option. Do I want to go find B first or do I want to go find A first? And it doesn't really matter. I'm going to go find A first. I'm going to write lowercase a for side A over sine of angle A, which is 37 degrees. I'm going to multiply my 37 degrees over, and I'm going to get 18 times sine of 37 all over sine of 95 equals A. And I'm going to put that into my calculator, and I'm going to find that A is approximately 10.87. At any time, pause the video and try to put this calculation in your calculator. Make sure that you're not getting a calculator type error because we want to make sure we figure that out for you. And now I have to do it all over again to find side B. So I'm going to start out with my original 18 over the sine of 95. That's my side C and angle C. I'm going to set it equal to side B over the sine of angle B, which is 48. Let's multiply that sine 48 over. I get 18 times sine 48 all over sine of 95 equals B. I'm going to put those into my calculator and get B equals 13.43. So let's flip it over and take a look at another example. Let's write in our information. So I know side B is equal to 75.9 inches, and angle C is 74.3, and angle A is 87.2. So let's go ahead and do 180 minus 87.2 minus 74.3. And when I do that, I find that my angle B is 18.5 degrees. So this is obviously not drawn to scale. So let's take a look at finding our side C and side A. So here we go, you guys. I'm going to start with a ratio that I know. One of the ratios I know is that the side B, 75.9, over the sine of angle B, which is 18.5, is equal to, and now I could go for A or go for C. It doesn't really matter. Let's go for C over sine of angle C, which is 74.3. So I'm going to multiply that sine of 74.3 over to the other side. And when I do that, I get 75.9 times sine of 74.3 divided by sine of 18.5. And when I put that into my calculator, I get that C is equal to 230.3 inches. This is what I meant by not drawn to size. So this triangle that we're using is really just for placement, because you'll notice that angle B is a really small angle, but C is bigger than it. It's 74 degrees, not 18. And you'll notice that side C is 230, which is way bigger than side B of 75.9. So in this case, the triangle that I was using could look like anything. I just wanted somewhere to write my numbers so that I make sure that I use the correct numbers, like the correct side length with the correct angle measure. So for example, I know that side A goes with the angle that's 87.2. So I'm going to use that to write another proportion where A over sine of 87.2 equals. Now I could use my new information I just found for C, but I'm going to go back and use my original information, and that was at 75.9 over sine of 18.5. I'm now going to multiply that sine of 87.2 over, and I get A equals 75.9 times sine of 87.2 all over sine of 18.5. So now my A is equal to 238.9 inches when I put that into the calculator. So I have solved for all my missing measures in this triangle. So I'm going to let you solve the next triangle. The measure of angle B should be 30 degrees. The side A should be 14.14 centimeters, and sine C should be 19.32 centimeters. So pause this video and try to do that problem and get those answers, and then come back to the video after you've tried it. So welcome back. Hopefully you were able to get these answers. If your work looks like my work, for instance, and you have wrong answers, it's probably a calculator error. So come by office hours with your calculator. Let's make sure that you're typing it in correctly and using equals when you need to. Good luck on your Law of Science homework, and I will see you in class.